Hello, my name is Jeff Abel, and welcome to the Arduino Quick Start video. This video is designed for students that have never used the Arduino microcontroller before. We're going to assume that you have no previous knowledge of programming, and we're going to start right from the beginning. You may have heard of the Arduino before. You may be interested in making a robot, you might be interested in making a machine, or maybe even doing some home automation that you can control through your cell phone. The Arduino is a digital microcontroller. Now, it has digital inputs and outputs, and it also has some analog inputs that we can use for different types of sensors. When we talk about digital is an on or off. It's 0 or 1, it's high or low. That's what we're talking about when we talk about digital. Analog is where we have a variety of values that can occur. And we're not going to go into all the detail of digital microcontroller, but we're going to talk about how to use it, and you just need to know a little bit about the digital. So let's take a look at an Arduino microcontroller. There are many types of Arduino microcontrollers. We are going to focus on the Uno. The Uno is one of the most popular Arduino microcontrollers. So here on the Arduino microcontroller, we have a few different components that I want to point out to you. We have our input and output pins. So these are our digital input outputs. They are labeled from 0 to 13, so we have a total of 14 digital inputs and outputs. There's a couple other pins that we have here that we may use later. We have a reset button. We have a USB connection that we're going to connect up to the computer with. We also have a DC power port. We have some other headers which have our analog inputs. And we have our ground, our 3.3 volt source, and our 5 volt source on this side also. Those are the main pieces that we'll be concerned with. There are a few other jumpers on here, but we're not going to discuss those in this video. The next thing that we're going to do is hook the Arduino up to the computer. First thing we need to do is connect our cable to the Arduino through our USB connection. Then we're going to hook it up to the computer using our USB, and we're just going to plug that into the front of the computer here. The computer will then recognize the board and connect up to it. It should automatically install your drivers for you. Next, we need to load the Arduino IDE and start the programming. To load the Arduino IDE, we go down to our Start menu, All Programs, click on Arduino. That will load our IDE. If you don't have the IDE loaded or downloaded, go to Google and Google Arduino IDE. That will take you right to the Arduino page that you can download the IDE and install it yourself. Once the IDE is loaded, we come up to the screen here, and we have a menu at the top. There's a toolbar on the next line down, and then we have what we see as a sketch. When we talk about sketches in Arduino, we're talking about our programming. So the program is really considered a sketch. First thing that we want to do is hook up the Arduino or tell the program which Arduino we have. So we're going to go up to the Tools menu and click on Board. And when you click on Board, you'll see that there are a lot of Arduinos that are listed. These are all the different types of Arduino boards that this IDE works for. Again, we are going to be using the Arduino Uno, so we just want to make sure Arduino Uno is selected. Next, we need to tell the computer which COM port the Arduino is on. To do that, we'll go up to Tools, click on Serial Port, and now we need to select the COM port that our Arduino is on. If we don't know which one our Arduino is on, I'll show you how to do that in a little bit. But we want to select the correct COM port. In this case, my Arduino is hooked up to COM port 4. So now we're all set for the Arduino to communicate to the IDE. So let's take a look at a sketch or a program for the Arduino. The nice thing about the Arduino is that they have many different examples. So we can click on File, Examples, and go under Basics, and the starting program will be called Blink. Blink is a program that will help us identify the basic structure of the sketch for the Arduino. So taking a look at Blink, we can go down here, and you can see that there's a bunch of gray text. Those are all comments. Those are not part of the sketch or the program, are not executable commands, but they're just giving us information. The first command that means anything in a sketch program is this void setup with the brackets. And if we take a look down a little further, there is a void loop with some brackets. Those are the two sections that are in every Arduino sketch. is the setup and loop. The setup is used for commands that only need to be run once. Our main sketch, our main program, is going to be in our loop section. And the loop will actually continually loop in there until we tell it to stop or exit the program. So let's take a look at those in more detail. So in this case, we have under blink, we have our void setup, and we have a command called pin mode. Pin mode is going to identify our input and output pins as either an input or output. So pin mode, parenthesis, 13 means pin 13, comma, and then we're telling it it's an output pin. So we're going to declare it as an output. That means that the Arduino is going to be using that to output information. And that's the only command that we need to run in our setup. Next, we have our loop command. So in our loop command, what we're going to do is we're going to turn an LED on and off. We're just going to have it blink. This is considered a digital output. And the LED is connected to pin 13 on the board. And I'll show you that in just a moment. But the commands are digital write. Digital write says that we're going to send information to one of our output pins. And in this case, digital write 13 says I'm going to write to pin 13, and I want to set pin 13 to high. Now high means it's going to turn it on or give it 5 volts at that pin. In this case, setting that pin 13 to high is going to turn the LED on. Then we have a delay command. Delay is just a pause. It's just going to tell the program just wait for a certain amount of time. In this case, the number that we have in the delay is the number of milliseconds. So when we have delay 1000, that's 1000 milliseconds or 1 second. So we're going to wait for 1 second. Next we have the digital write on pin 13, which sets it to low. Now that's going to go to 0 volts. So that's going to turn the LED off. And then we go back to our delay for 1000, which we're going to wait for 1 more second. And then we have the end of our loop. And since this is our loop, it's going to continue. So it's going to go back up to the beginning and repeat. So it's going to turn the LED on, going to wait for 1 second, turn it off, wait for 1 second, and then loop up and do it all over again. Now that we have our program, we need to get it from the computer onto our Arduino. To do that, we're going to compile it and it will download. So at the top of the screen here, we have a little arrow that's pointing to the right, and when we hover over it, you can see it says upload. We want to click on that button, and it's going to start compiling. So it's going to then take our program and make sure that we have it written correctly, the correct syntax, and then it is going to download it to the Arduino. If it is successful, it will say uploading or done uploading. And the program will now be on the Arduino and we can see it running. It'll start running automatically. Now we can see the program running. We can take a look at the LED, and now it is on for 1 second, it is off for 1 second, and it will continue to run. Next, we're going to make a basic modification to the program. So instead of blinking for 1 second, let's have it blink for 1/10 of a second. So on for 1/10 of a second, off for 1/10 of a second. So let's modify the program. We're going to go in, and under the delay, instead of waiting for 1000 milliseconds, we're going to wait for 100 milliseconds. So I can just go in there, highlight my 1000, just put in 100. And I will do that for both of the delay commands. Now that I've modified the program, I want to download it to the Arduino. So again, I'm going to hit the button with the arrow to the right, which is our upload. It will then recompile and download the program. Now we can see that the LED is blinking at a much faster rate, at 1/10 of a second on, 1/10 of a second off. We had to tell the computer what COM port our Arduino was on. If you didn't know, you might have selected one of the COM ports, and I want to show you the error that you'll get if you select the wrong COM port. So I'm going to go and intentionally change my COM port to one that's incorrect. So if I go under Tools, to my serial port, I pick COM3, which I know my Arduino is not on, but let's say I want to download this program to my Arduino, but I had the wrong COM port. If I hit upload, it will compile the sketch, but it won't be able to download it because it can't find the Arduino because it's on the wrong COM port. So you can see that it's downloaded, or it's compiled our sketch, and now it's trying to upload, and it says done uploading, but we get an error. This AVR dude, it says not in sync. That's the error that you'll get when you have the wrong COM port. So if you get that error, go up under Tools, go to your serial port, and select a different COM port. The Blink program deals with only digital outputs. There's no input. Once we download the program, it will continue to run and the LED will flash until we turn it off. But when we deal with microcontrollers, we want to have inputs that will control outputs. So what we want to do is take an input, have the Arduino do something with that input, and then control an output. So what we're going to do next is we're going to deal with another program that we're going to introduce a digital input. And a digital input that we're going to use is a button. So we need to hook up a button as a digital input, and we're going to use the LED on the board and control the LED. So the next program we're going to use is called button. So let's load that up. We can go onto our IDE, go under File, Examples. Now instead of going under Basics, we're going to go under Digital, and we're going to select Button. That will bring up our button program. Let me just close these ones down. Now we have our button program. Again, it has a bunch of text on here that shows, that describes the program and what we need to do. Now the nice thing about some of the examples that the Arduino has is they have hyperlinks to some more tutorials. So if you click on this button, the tutorial, it will actually bring up some information, and I'm going to arrange this such that we can see both of them here. There is some additional information about this program. Now what we'll notice with the button program is that we need some other hardware. We need a resistor, we need a breadboard, we need some hot wire, we also need a switch and our Arduino board. Now, once we get all of those components, we need to know how to wire it up. The nice thing is here is it shows how to wire it up. So we have our Arduino, and we have our breadboard, we have our button, our resistor, and all of these other lines are wires that we're going to need. So there's blue, red, black, and black. We won't need to deal with these other ones on the right-hand side. So let's hook this circuit up so we can run it. So I've gathered my components that I need. I have my breadboard, I've got my jumper wires, I've got my button, my resistor, and my Arduino board. So the next thing I'm going to want to do is take these components, follow the tutorial on the screen, and hook them up so I can hook it up to the Arduino. So let's do that now. I've now wired up our components onto our breadboard. A breadboard is used to help make electrical connections or electrical circuits without having to connect the wires together physically. We can just slide them into the breadboard, which makes the electrical connection. Let's go over the breadboard. For those that haven't used breadboards before, there's just a few things that we need to know. You'll see that there's a blue line and a red line right next to these rows of holes. Same thing up here, there's a blue and a red on these right there. So what it is though each one of these holes are electrically connected together. So this row is all electrically connected together, and then the row next to the red is all electrically connected. But those are not connected together. The blue and the red are not connected together. So any wire that we put into these rows on the red one will be connected together, and the same with on the blue. So those are the outside 4 rows. Now on the inside here, we have a lot of holes in the middle. And in this case, the holes are connected together electrically in a row. So there's 5 holes, and those are all connected together. But right next to it, there's 5 more. Those 5 are connected together, but they're not connected to the one right next to it here. So it's just the 5 rows, the 5 holes are electrically connected together. So if you take a look here, I have my resistor in one hole here, and in that same row I have my wire. That means that these two are electrically connected in the circuit together. Same thing back over here. I have my green wire, I have my resistor, and I have my push button connected all together on that one side. Now when we go across to this side, these 5 are separate from the ones on this side. And again, it's these 5 holes are all electrically connected together, but they're not connected to the ones next to it to the left or right. So that's how we can hook up our circuit. So here I've got my positive, our negative, and our pin. So let's hook this up to our Arduino. Again, I'm going to take a look at my circuit on the screen. Make sure I've got this hooked up. So my green wire is going to be hooked up to pin number 2. So pin number 2 is right here. Now remember, when we're talking about digital, we always start counting with 0. So pin 2 is actually the 3rd hole up. It starts with 0, 1, 2. So I've got my I/O pin connected up. The next I'm going to connect up my 5 volt and my ground. So based on my circuit, my yellow cable here is going to go to my 5 volts. And my white cable is going to go to the ground. And my cable colors do not match the diagram on the screen here, but just need to make sure you get the correct one going to the correct location. Now we have our circuit hooked up on our breadboard, and it is electrically connected to our Arduino. We are now ready to start the program, and we're going to download the program. All right, now let's go back into the sketch and take a look at the button program, or the button sketch. If we take a look here, we have some text. Now, we also have a few commands here. There is a const, C-O-N-S-T, and that says that's a constant. So this is a variable that we're going to set, that we're not going to change. And it says int, which is an integer, and then we have our button pin. So we are going to set a variable that is going to represent our button pin number. So our button pin is number 2, and in the program or in the sketch we're going to be using button pin instead of the number 2. So when we're reading it, we'll see button pin and not just the number 2. It makes the program a little easier to understand. And we also have the next one, which is our LED pin. So we have const int, so constant, integer is our type, LED pin is equal to 13. So we're going to set the LED is on pin 13. So those are 2 constants that we're going to set. We also are going to set our button state. And now our button state is going to change. A constant does not change. We're going to set it once and it's going to stay that way the entire program. But our button state, if we're pushing it or we're releasing it, is going to change. So we need to just set that up as a variable. And in this case, we're going to have an integer, an integer variable. So we'll say int, button state is the name of our button, or name of our variable. And we're going to set that initially equal to 0. Now, this initial set to 0 it will automatically change based on the state of our pin, but we're going to make sure we set it to 0 initially. Now we get down to our setup command. The setup has a couple commands in it. We could actually included the ones above it, but this programmer has decided to do it a little bit different. Not a problem, it still works either way. But in our setup, we're going to set up our pin mode. So we have our pin mode. Again, we have our input and output pins, and we're going to tell it, is it going to be an input or output? Well, our button is going to be an input. So we need to tell the Arduino that we're going to be taking information into the microcontroller through the button pin, and we're going to have an output. The Arduino is going to control something with an output pin, so we're going to tell it which output pin. So in this case, our pin mode, our LED pin is going to be set to an output. So remember, LED pin, that's going to be pin 13 because we have that constant, and we're going to tell it that's going to be our output. Next, we have our pin mode, button pin, and that's going to be our input. So that'll be our input. So now we've declared our variables, we've set our pin modes. Now we can get into our actual sketch or the program that we're going to be running. So first thing that we're going to do is the way that this program is going to work is we're going to look at the button. What is the state of the button? Is it pushed or is it not pushed? If it's pushed, we're going to turn the LED on. If it's not pushed, we're going to turn the LED off. So let's look at how we do that on the screen. So first thing we're going to do is we're going to say our variable button state is going to equal digital read of our button pin. So what this statement says is that our button state is a variable, and we are going to read the state of our input pin. And the input pin, remember, it's digital. It's on or it's off, or it's 0 or it's 1, or it's high or it's low. So we're going to be dealing with high and low. So we don't need to know if it's 0 or 1 or whatever. It's either going to be high or it's going to be low. So once we read that, our button state will be either equal to high or low. So now we're going to go down and check our button state. And we're going to use statements called if-then statements. So the first thing is we're going to say if the button state is equal to. Now the one thing that's interesting with the if statements is that we need to have a double equal sign. That means that that's a logical operator, and we're not setting that variable equal to some value. So we're just saying, is it equal? So we need to use a double equal sign. So button state, double equal sign, high. So if the button state is high, then we want it to do something. So we'll have our little bracket, and we're going to turn the LED on. So we're going to say digital write, our LED pin, and we're going to set the output pin to the high. So that will turn on the LED. So digital write, LED pin, turn it on. And then we're going to have our end bracket, which then finishes our if statement for the true value. So if button state is equal to high, then it will complete all that, and then it'll go past the bracket. Once it gets past the bracket, we have this else command. And it says else, and what that means is that if the first part is not true, then do the else command. And the else basically says if it's not high, it must be low. It can only be in one of those two states. So the else is if it's low. So we're going to say digital write LED pin low. And that is going to turn the LED off. And that is the end of our program. So again, in our loop, we're going to check our button state. We're going to see if the button is pushed, then we're going to turn the LED on. Otherwise, we're going to turn the LED off. So the next thing we need to do is download the program to the Arduino. So again, we're going to hit the upload button, that right arrow. It is going to compile our sketch, and then it's going to download it. Now that the sketch is downloaded, we can then see it in operation. It automatically starts to run. You can see the LED is off and the button is not pushed. Now if I push the button, the LED comes on. And again, because of the loop command, or the loop section of the sketch, is that it's going to continually run this. So as I push the button, it will check to see if it's pushed. If it's pushed, it'll turn it on. Since I've released it, the program is checking the button state. The button state is low because it's not pushed. Because it's low, it turns the LED off. And in this case, all we're doing is turning it on and we're turning it off. This is a very simple example, but this is the primary way that microcontrollers work. They take an input from the environment, they do something with that input, and then they control an output. So this could be something as simple as on your phone, you could have an app that you're going to turn on your lights at your house. You could push a button on your phone, which will then communicate to your Arduino. The Arduino is going to take some of that information, and then it will control an output to turn a light on. So it's a little bit more complicated than this simple circuit, but this is the fundamentals of what you need to know. Digital input is controlling a digital output. Now we've really covered the fundamentals of the Arduino. We've talked about the Arduino, how to hook it up, how to load the IDE, looking at sketches, and running, compiling, and downloading those sketches onto the Arduino. At this point, you really have those basic tools to be able to go out and explore some more. So let me show you how and where you can explore. One area is in the Arduino IDE. So we took a look at just two programs, but if you go under File, Examples, you can see there are a lot of other types of programs. So if you want to look at sensors or look at some analog inputs or other displays connecting up with USBs, there are programs on here that are good examples that you can learn from. So if you want to try to learn from other programs that are already written, they're on the IDE, which is a great place to start. You can also go out and look on Google. If you Google Arduino or any type of program that you're interested in, you'll probably find it. Arduino is an open source platform that has a large following, and there's a ton of information out there. There are two other resources that I would recommend, two books. First is Programming Arduino, Getting Started with Sketches by Simon Monk. This is a very good basic book. It covers all the programming commands that you would need to get started. It covers the basic operation of the Arduino, and it's very basic, and it actually gets into some very advanced topics by the end of the book. If you're beyond the basics, I would recommend Programming Arduino Next Steps. This is also a book by Simon Monk. It is very good with advanced topics, so if you want to get into more advanced programming techniques or efficiencies, this is an excellent book to get into. I would recommend both of these. Full disclosure, I have no association with Simon Monk or the publisher. Thanks for watching, and enjoy programming your Arduino.